Next up is another tech talk, which really encompasses what we can learn from the great architecture of a product. So I'd like to welcome on stage Marco Cecconi from Stack Exchange to tell us about the architecture of Stack Overflow.
Hello. So good evening. I'm going to talk about the architecture of Stack Overflow. So I will start with a simple question. How many of you are already familiar with Stack Overflow? Like everyone, okay. So the first thing I'm going to talk about is I'm going to describe a bit the kind of problem that we're facing, right? So every good architecture is built around solving a problem. So what's our problem? Okay, so our problem is that we have, sorry, this doesn't really, yes, that's the problem. Here we go. So we have around 100 sites now. Each one is a different Q&A site about a different topic with its own communities, own identity. We have around 4 or 5 million users. We have 40 million answers and 8 million questions. So a lot of big numbers there. So another way to see this is that, yeah, there are many different sites, each one with his own identity, as I was saying. So we are number 49, number 15, depending on the day, network in the world, and number 14 in Romania, so thanks about that. What does this mean, though? This means that we serve around 500 million page views per month, and that's pretty large numbers. And the kind of problems we face are fairly unique. Of course, we are not Facebook at all. They are like 100 times bigger at least, but we're still pretty big. So this is our data center. So there's exactly maybe 25 servers there. That's all that there is. Normal sites, other sites with the same kind of traffic, they tend to go around 250 servers maybe. So we are 10 times smaller. And this talk is about how come? How can we be so small? How can we be in this situation? So this is our architecture, if you like, our physical architecture. We have 11 web servers. We have 2 load balancers. We use Redis for caching. We use Elasticsearch for search. And we have very few databases. We have 4 active nodes, and that's all that there is to it. There's nothing much. We keep the architecture small. Do you guys think this architecture is small or is very large, or no idea?
Small, very small for the size.
Yeah. Yes, it is very small. And not only that, but this is our status board. Of course, it's not live because this is just a slide. But as you can see, our databases and our web servers are really working below capacity. Everything is going around 10%, 15%, 20%. The 2 SQL servers that you see here who are orange is because we set the limit very, very low, around 20%, where we start receiving warnings. And the reason why they are so high is because we were taking backups while I took the screenshot. So the reason for this, and so what this means is that, yes, we have 25 servers, which actually run on 5 servers. If we were crazy enough to have no redundancy whatsoever and really, really stuff everything like to the maximum. Of course, we don't do that, yeah? But yeah, we tend to be pretty small. So we're still scaling up. So many companies will tell you, you need to get, big scale, big data, big everything. And yeah, sure, we'll do it, but we look at the real data that we have, the real numbers that we have, and we don't need to. As you can see, our servers are underloaded, and there are few. So that's what we do. We are scaling up, not scaling out. Other things. So how do we manage to get this, right? Because there are reasons. And one is that we try to keep everything small. Everything is small. this is our source code, and we only have 8 or 9 projects. It's really, really small. Normal .NET projects of large software bases, maybe they can go even up to 100 projects. We keep it to 9. The reason for that is that compilation is faster. So we can compile the whole of Stack Exchange network in 9 seconds. Few lines of code, again, the same thing, right? We have 100,000 lines of code. That's all that there is to it. There are a few tricks up our sleeve why we can keep the number of lines so low. One of the tricks is that we do a lot of libraries, and we'll explain later. And the other one is that the logical architecture of our software is really, really tight and really compact. So we don't have many layers. We don't do dependency injection. We don't do a lot of things that everybody takes for granted. So we break all those rules because they don't work for us. And the consequence of that is not so good. And well, it's good that in that it works. It's good in that our software is really fast. But we have very few tests, unfortunately. We just have and the databases are actually run from memory. That's why we have 384 gigs of RAM, not of disk. And then we use really, really fast solid-state disks. So everything is as fast as possible. So to give you an example, we are really focused on this, and we created great tools to make this easy, right? You don't want to bring in a lot of friction in order to use caching properly, because we cache so many things and we are so keen on it. So this is our help center. This is the first feature I built at Stack Overflow. So it's a page, it's basically a CMS where there are pages about how the network works and what are the rules and so on. So all the content in here is clearly cached. It comes from the DB and is cached. So the code to get the data out is not that big. It's exactly this, and it's 10 lines of code. Yeah, so as you can see here, I think this is a good example. So it has all the bad things that we do to make it faster. It's got static methods, which you should never use because they're not friendly with unit tests, but they're really fast. We have getSet. That getSet method is our own library to access all the caching. All the caching is done in that one line. And we also show that to access DB, we use a library which we built, which is called Dapper, which is really powerful. I mean, all that is needed to get a table out of the DB into a set of objects is that one line of code, line 214. So really powerful tools that allow developers to be very, very efficient and the code to be terse as possible. Few lines of code, as I was saying, a lot of caching, a lot of technologies like this. So cache all the things. So this brings me to another point, which is square wheels. So are you familiar with the saying, reinventing the square wheel? Yes? No? Hands? Nobody knows it. Someone knows it. Okay, so it's a computer engineering term, which means that your newbie developers, they think they can do something. Oh, I will do a new MVC framework, and I'll write it myself, and it's going to be better than the ones that are provided. And this is seen as a bad thing, right? So because people reinvent something which is already there, which no one really needs to reinvent, and they do it broken. So the wheel is square, yeah? So people think about this. So unhappy child with broken wheel. Instead, we do reinvent square wheels all the time because we think about this. So this guy here, Professor Steinwagen, discovered that if you have a particular kind of road where all is really bumpy and is shaped like a catenary, then if you use square wheels, you actually go smoothly. And if you have round wheels, you're just all bumpy. So we are in the same situation. So every day we are doing stuff that probably nobody has done before. Microsoft comes to us and says, okay, can you test our new software for us? Because you are in a unique position. And that is great, but that also means that not everything works for us. So we keep on rebuilding stuff. So data access, we built our own data access library. We built so many different technologies. And what we do with these things is we package them up and we open source them. So we have like many different open source systems that we're giving back to the community. You can do half the site probably just by patching together these libraries. And so there are many reasons why we do this. One is it keeps the code clean, right? So you package something away, you give it up to someone else, you don't have the source code anymore in your tree, you don't have to compile it every time. It's a fixed bit of the framework. That also forces you to do it right, to package it, to get it done, to get it finished, to test it. And this keeps everything, again, tidy. And also, you need less tests, you have fewer lines of code, you have fewer projects, everything is more compact, everything is faster. Your feedback cycles are faster, and everybody's happy, and you deploy 5 times a day. So reinvent a better wheel if you can. This is very important to us. We keep on doing it. The latest release that we did is of our status server, which is the thing you saw a screenshot of, that we open sourced it last month. So other stuff, key for us is a great team. So this is my team. As you can see, there are around 30 people. Out of these, probably maybe less than about a third are actually developers. Everybody else is doing something else like design or community management or product management and so on. So we are a very small team. And the key for that is that we want to have an excellent team, a very functional team, a very quick, fast team, but not big. And how do we build it? So we have a particular way in which we build our team. So the first thing I told you already is that we are all remote. So everybody works from home, pretty much everyone. Another thing is that we love geeks. Like everybody in the company is a geek. So you know who these guys are? Yeah? It's Microsoft, right? Yeah. So Microsoft probably at this time was really awesome, at least I think. So they were all geeks, right? There was no Balmer. And so we try to keep that. We try to keep it super geek friendly. Everybody in our company, or almost everyone, not the cooks, but most people are actually developers. So our CEO is a developer, our graphic designers are developers, believe it or not. Our product, so we get specs in forms of SQL queries sometimes. So it's very geek friendly. And that's key, because you create a community of people that actually understand each other. Another thing is for developers, don't be afraid. Always go down to understand the stack completely in depth. So we routinely go down to and do IL, which is the intermediate language, is the machine language of .NET. We go down to that level every time. We try to understand how everything works. In SQL Server, we look at query plans. We look at all the details on how the nitty-gritty, the indexes. Everyone is a DBA. Everyone really tries to understand how things work. Another thing is how you hire people. So we hire people. We have a track record of being super smart, but also a track record of getting stuff done. We don't want architectural astronauts that, they're really smart but never get anything done. On the other hand, we don't want people to put down tons of code which is not really great. We want both things at the same time. And tools. Tools are fundamental. You hire great people, you create a great team, and then you don't give them the tools. That's ridiculous. Yeah, so every other company you work for, you need to get ReSharper, whatever, your tools that you use on your everyday job, you have to ask for it, you have to justify it, you have to go through bureaucracy and wait months to get a tool that will save you overall a week of work over a year. And then it costs you 2 weeks to actually convince someone to actually pay 300 euro for it or whatever. That doesn't happen there. If you need something, you get it usually within 24 hours. If it's harder, it takes a bit more, but it's always under a week. And that's really important. It's, again, promoting efficiency, promoting people thinking about the actual coding problems, not thinking about how do I justify using ReSharper. It's not really interesting to a developer. And that's it. So that's it. This ends my my presentation. So I guess I'll take questions now.
Thank you for that presentation. That was awesome. And here's the first question.
Hello.
Yes,
Sorry.
hi.
My name is Ciprian, and
Yes.
I use many Stack Overflow communities from super user, Stack Overflow, Drupal, etc.
Yes.
I mean, I know that your software is great, it's fast. I mean, I wish my websites were that
Right.
fast. But I'm not very clear. How do you monetize all this work if you open source so much?
Oh, that's very simple. Actually, one thing I didn't have time to mention is that not only we open source as much as possible of the code, and the ones we don't open source is not because we are against it, it's just because it's probably a bit too messy or is not packageable in a way that someone else would find useful. But we also give away all our content. So you can go and download a torrent, which is updated every 3 months, of all the content of all our sites. That's all open to use, licensed for use. We are very, very friendly toward those kind of things. And the reason for that is that our value is not our software or our information, it's our communities. And the communities, nobody can take away, really. So
Very cool. Next
we
question.
monetize communities.
Yes, you have a mic.
Thank you. Hello.
Hi.
My name is Vlad. Thanks for doing this.
Yes.
Quick question. You said you're doing about 5 releases every day. If something goes wrong, how do you roll back? Do you have a release manager, or how do you know you need to roll back some code because?
Oh, it's up to the developers.
Okay, so they do it themselves, basically.
Yes, yeah, maybe I wasn't clear. I do everything from writing the SQL to the JavaScript to pressing the button that stuff goes live. If they took away all the other developers, I would be very slow, but I could probably do and go on with any task that is there. And this applies to everyone.
Okay.
So yeah,
Thank you.
full stack.
Other questions?
Yes.
My name is Dragos, and I actually have one question.
Yeah, sure.
Stack Overflow has a lot of users. I mean,
Yes.
a lot of people use it. And you only have one server, which is located where?
We don't have one server. We have 25.
Oh, you have 25 servers spread around the world. Yeah, that's
No. They're all in one place.
They're only one place?
They're all in New York. Yes.
And how do you get such a fast page load time from Romania? Because it's quite a distance.
Well, the answer. I mean, how much time do you have? But yeah, it's CDN, of course. So we have a CDN which delivers all the static content, and that content will probably come from a server in Romania for you. So that is one reason. Another reason is that we obsessively monitor all the page render times. So we have a tool called Mini Profiler, which is one of the open source tools. Basically, what it does is, for all the developers, it puts in a small window next to the site, which tells you exactly how long this page render took, how much time did we spend in SQL, how much time did we spend looking up the cache, and so on. And that obsession over these kind of things allows us to be very optimized. So we do a lot of things out of this, but we measure everything.
Because I was kind of comparing it to Google, well, not really the users, and your page, I think it loads faster, a bit faster than Google.
Oh,
Yeah.
well, I don't know.
And
They're
Google has like millions of servers spread around the world, and you only have one. I'm 25 in one place, and that's just amazing.
Yeah, thank you.
Thank you. Other questions? We will take one more. If not, Marco, there we go.
Hi, my
Hello.
name is Tudor.
Yes.
One very technical question is, do you only use .NET or do you have some native code there that gets you the raw power?
So we don't have any, if you like, assembler code. But we don't only use .NET. So our, for example, our load balancer, which do an excellent job there, HA proxy, which is Linux-based, Redis is Linux-based. But in most cases, the worst case scenario is that we need to write some IL, some .NET assembler. After that, it doesn't really matter to go any faster, I guess.
Thank you.
Yeah.
Thank you so much, Marco.
Thank you.
Marco will be available for talks. You can find him around the conference. Thank you very much.